Hello, today I'm going to be doing a presentation on Siliciclastic Continental Shelf Environments. So this is just a picture of a continental environment, and we're going to be focusing on this area right here, the shelf. So what is the continental shelf? First of all, it's located at the continental plate margin, where you're having one a continental shelf and a subducting plate. This usually extends from coast to shelf edge around 200 meters. This is 200 meters. It is generally flat and underlain by different continental crusts, and they are usually rifted. This continental shelf environment is affected by waves, tides, currents, and sea level changes. The continental shelf on both the passive and active side. So, depending on the type of plate margin, you can have different types of continental shelves. This is because the type of margin dictates the amount of space the continental shelf has before the shelf break and then going down onto the continental slope. In a passive margin, as you can see on the left side of this bottom image, you can find you have a larger continental shelf and with the ability to have more of a flat surface. While on an active continental margin, you're having a much shorter continental shelf together with a steeper continental slope. So a type of passive margin is an Atlantic type, and an active margin is a Pacific type continental margin. So shelf environment, the siliciclastic shelf environment is bounded depending on the type of uh, continental plate boundary it is at. And depending on those plate tectonics, it can determine the different sizes of the different subsections. So in this diagram, we find it's split up into four different shelf. The shelf is split up into four different areas. So this is the shore face, the inner shelf, the outer shelf, and then the shelf break, which then goes into the continental slope. The shallow inner shelf is dominated by tidal, wind, and storm wave processes, while the deeper outer shelf is affected by intruding major ocean currents and density currents. So on these different shelves, there's two different types of sediments. So there's modern sediments and relic sediments. So modern sediments are sediments that are deposited onto the shelf during the current processes that are affecting the shelf at that moment, while relic sediments are previous deposited material that was on the land and has been transported there by rivers or glaciers or activity that has happened previously before, uh, such as lowered sea levels. And all of these different rivers and glaciers can happen at different sea levels, and that would depend on the size and the different grain size of the sediment that is deposited on the shelf. Depositional processes. So previously, continental shelf was thought to just be a graded shelf, so with the largest grain size on the inside and the smallest grain size on the outside, depending on the amount of force that is affecting the shelf due to depth. So this was found to be incorrect due to the relic sediments that were deposited on the shelf before the modern sediments. These relic sediments have irregular grain sizes and are distributed all throughout the shelf. The grading is irregular due to the depth changes on the shelf environment and to the relic sediment being deposited onto previously deposited sediments. Four types of currents rework and transport the modern sediments onto the shelf, including tidal currents, storm generated currents, and ocean currents, as well as density currents. Therefore, the shelves have been divided into three different primary types. These include storm or tide dominated, storm dominated, and intruding ocean current dominated. So we'll first start off talking about tide dominated. So this includes 17% of the world's continental shelves, and at these different localities, we find it's primarily controlled by the daily rise and fall of the sea level. This rise and fall of sea level is due to the moon affecting the ocean, and this vertical sea rise also is accompanied with different horizontal movements of the water due to different currents. These currents are bidirectional and affect the sediment decreasing as water gets deeper or decreasing with depth. Some of these tidal currents are strong enough to rework and transport sand as well as small gravel, while other tidal currents do not have any effect on the shelf sediments. Waves that are created by the tides or with the tides just aid in the movement of the sediment. So, telltale signs of a tide dominated shelf include large dunes on the outside with tidal sand ribbons, which are large scale bed forms which are ridges parallel to the tidal flow, as well as some other small bed forms are found in different sheltered environments. So this is an area we can see we're having our large dunes on the outside, and while continuing towards the shelf, we're or outside of the shelf, we are looking at our side sand ribbons, and then finally followed by later furrows and gravel waves. So this model is dependent on the different amounts of sands. So in the continental shelf environment, we'd have more sand ribbons, and continuing up the con towards the end of the shelf. While in a high sediment model, we find we have a larger amount of dunes when compared to ribbons. So in storm-dominated shelves. So 80% of the world is dominated by storm-dominated shelves. Storm-dominated shelves are very important due to this fact. So we find storm-dominated because ocean waves are caused, or one of the main um, forces that create ocean waves are storms. Different winds as well interact with the water and create an orbital wave motion, which picks up sediments and places it in a suspension. This movement has varied velocities depending on where it is in the water column, and it deposits along the shelf depending on grain size. So how this happens is the wind interacts with the water and it creates a spiral effect. So the wind gradually moves it to deeper layers of the water, and it is affected by the Coriolis effect of the Earth, which is generated by the Earth's rotation. Most of the wind forces produce flow parallel to shore and don't impact offshore sediments due to it only is affecting the top layers of the water as the interaction between the water and the wind. Storm-dominated shelves may also be very complex, depending on the amount of relic and modern sediments. Generally, you're finding seaward finding in these types of shelf environments with different storm layers and hummocky cross stratification. So these storm layers and the cross stratification is one of the best ways that we can identify storm-dominated shelves due to the fact we're having extremely high amounts of wind and different storms coming through. We find we're having a lot of cross stratification. So in our core storm events, we're finding we're having uh, a storm event followed by a later point of quiescence. As you can see, we're finding larger gravel um, in the coarser grain beds, while in the finer grain beds, we're finding more hummocky cross stratification as well as different ripple cross stratification with obviously finer grain size. Finally, shelves dominated by ocean currents only account for 3% of the world's shelves, and this is due to the different density currents and the salinity of ocean water or water from the ocean or fresh water. And this allows for the suspension of different sediments in the water column based on the density of the water. It is important mainly in transportation of fine-grained sediments, and the circumstances maybe the fine-grained sediment flows seaward based on the currents of the bedding surface, and all the water transported in rivers going towards the areas of lower elevation. So, telltale characteristics of intruding ocean currents. Well, these only occur at very unique spots where we're having a freshwater source going into a ocean source. So we're finding these at only coastal environments, such as the southeast coast of South America, as well as the Taiwan Strait. So depending on the locality, we're finding sedimentation primarily just in small scale bed forms, as well as the different relic sediments affect the new bed forms being formed. Finally, two different factors that can affect the coastal shelf include sea level change and biological activities. Sea level change can affects the fluctuation of erosion and depositional amounts of sedimentation and processes. This affects the shelf and can allow for different bed forms to be formed and then completely erased, depending on the amount of sediment that's being inputted and the current types. Finally, biological activities affect the continental shelf in different ways. This is because large populations of organisms can live on the shelf, and these organizations can feed off of the sediment that is being deposited, and that can have effects of possibly establishing the continental shelf or depleting its resources through different environmental factors and niches. So it's very much dependent on the specific locality and what biological activities are occurring on the shelf at that locality. Thank you for watching the presentation.